Alright, so in section 2 we talk about binomial probabilities. And so in binomial probabilities, we have two different things that can happen. It's like if I'm a basketball player and the probability of making a free throw. I'm either going to make it or not make it. So a binomial means we have two possible outcomes. And so I want you to get comfortable using StatCrunch, as always, but making sure that you can see that it's a binomial probability because there's two events that can happen, and then how to find those probabilities. So the texts give a pretty awesome way to find the probability, and there's this gnarly formula that you are welcome to use if you want. And one more over there. And so the formula is available to you. It uses combinations, something that we talked about in chapter 5 with combinations and permutations. But here's the formula. So it's used in a combination of how many items you're choosing out of your group, the probability of that item being picked, and how many times it's picked, times the probability of it not being picked, and how many that it's not being picked. So let's go back to free throws. So let's say that I'm a basketball player. To find binomial probabilities, I'm going to go to my binomial calculator. So under calculators, binomial. And so let's say I'm making 10 free throws, and I'm going to say I'm an 80% free throw shooter. When I hit this, it's going to give me the probability of certain things. The probability that I make 5 of my free throws, if I am an 80% free throw shooter, is about 2.5% of the time, 2.6%. To make 9 of them, I have a pretty good chance, 27%. But again, we notice that the highest one is at 8. Does that make sense that it would be at 8? If I'm an 80% free throw shooter and I'm shooting 10, we would expect, my expected would be I make 8 of them. But, you know, I could make as little as 0, right? It would be very unlikely that I would make 0. So here's how we can find some equals to. We can do less than or equal to, greater than or equal to, less than, greater than. So like this one would be at least, like what's the probability I make at least 5? Right? You would think if I'm an 80% shooter, I'm going to make at least 5, and it's pretty good. Right? We get this nice visual of what's going on. What's the probability that I make in between 4 and 8? So somewhere in between there. And it gives me these probabilities. So very handy calculator. I'm a fan of this. One thing I'm going to show you is if we look at this, like this is kind of skewed to the left because the tail goes off to the left. As we increase our sample size, look at the picture. The picture looks more normal. That's something that's discussed later. But for any shape distribution, whatever the shape looks like, ours was skewed. As we increase the sample size, we're going to eventually get something that looks normal. So, and this is a great way to visualize that using this calculator. See that visual of that. Notice to get in between 4 and 8, it's pretty unlikely. But we would think that the highest one would be 80 because 80% of 100 is 80. So let's find out what that probability is. To make exactly 80 is about a 9, almost 10% of the time I'm going to make 80. But, I mean, it's probably, if I'm an 80% free throw shooter, I might make 81 or 82, 75, something like that. So that's when we can kind of look at a range let's say that I want to make between 75 and 85. So I have an 83% chance of making within that, I guess, window of 10 free throw shots. But the questions that, some of them are just kind of point blank, here find the probability that's less than or equal to 3. But sometimes they'll give you some scenarios like basketball, filling out a probability table. But the way you're going to find those probabilities, if it's a binomial probability, is just go here and plug in those values, and it'll give them for you. So awesome calculator, a nice visual. Also in the text, they talked about finding the mean and the standard deviation of a binomial. Oh, I was there. A binomial probability, and so we almost were figuring it out a second ago. Like if I was an 80% free throw shooter and I shoot 10, we would expect that I get 8. And we got that by multiplying our n times our p. And so that's how you find the mean, and here's how you find the standard deviation of a binomial probability. There is a formula to do this. So this was, so in the basketball example, if I was shooting 10, p is 0.8, and then I do a 1 minus 0.8, and all that's underneath the radical. So let's do that real quick just to verify and figure out a standard deviation to see how to do it with the calculator. So if I am looking at n times p, of course that's 8. But if I'm doing the standard deviation, it's n times p times, and I can either put in 1 minus p, or I could just type in 0.2 if you feel comfortable with that. And I get about a 1.26. So, kind of thinking of the empirical rule, plus or minus 1.25 would give me 68% of the population that shoots 80% are going to make it within here. So it just gives us some idea about how much our numbers vary. So that will pretty much get you through your homework. Let me look at number 10. I wrote that one down. And so again, this one's asking you to find the mean. So that's an n times p. It's probably also asking for a standard deviation. So that's the square root of n times p times 1 minus p. So I think using that calculator and those couple formulas down here will help you out through this section.